Artificial intelligence, two words that are shaping the future faster than we can imagine. But how exactly does it work? And what's behind the technology that's becoming more intelligent every day? Today, we're diving deep into one of the most mind-blowing technologies of our time, machine learning. Machine learning isn't some distant sci-fi concept, it's already here in your pocket, your car, and even in the way businesses and governments operate. In fact, according to a study by PwC, AI could contribute $15.7 trillion to the global economy by 2030. Let's break down what this really means. Traditional programming requires explicit instructions. If X happens, then do Y. This means that every possible scenario must be anticipated and coded by a human programmer. The computer follows these instructions to the letter without deviation. But machine learning is different. Instead of being programmed with specific instructions, machine learning algorithms are designed to learn from data. This allows them to adapt and improve over time, making them more flexible and powerful than traditional programs. It's a branch of artificial intelligence that allows computers to learn from data without being explicitly programmed. This means that instead of telling the computer what to do, we provide it with data and let it figure out the patterns and relationships on its own. The algorithm learns and improves by identifying patterns. As it processes more data, it becomes better at recognizing these patterns, which allows it to make more accurate predictions and decisions. Think of it like this. If you give a machine thousands of labeled images of cats and dogs, it uses a process called supervised learning to figure out what makes a cat and a dog a dog. Supervised learning involves training the algorithm on a labeled dataset, where the correct answers are provided, so it can learn to make accurate predictions. But here's the crazy part. It's not just remembering the pictures, it's identifying patterns in shapes, colors, and textures. This means that the machine can generalize from the examples it has seen to new, unseen examples, making it incredibly powerful for tasks like image recognition. This process was explained by Ian Goodfellow in his groundbreaking book, Deep Learning, where neural networks or layers of algorithms mimic the human brain's architecture. Neural networks are designed to process information in a way that is similar to how our brains work, with multiple layers of interconnected nodes that each perform a different function. Every layer of this network extracts more complex features from the data, just like how our brain processes information step by step, from basic shapes to full objects. The first layer might detect simple edges, the next layer might detect shapes, and subsequent layers might detect more complex structures like faces or objects. This is why deep learning can be so powerful. By leveraging the hierarchical structure of neural networks, deep learning algorithms can learn to represent data in increasingly abstract and complex ways, allowing them to solve problems that were previously thought to be impossible for machines. To really understand how machine learning works, let's break it down. Step 1. Data. The more data, the better the learning. According to DeepMind's research, even the most advanced algorithms fail without enough high-quality data. Once you have the data, you select an algorithm. For example, the support vector machine or decision tree. These are specific methods that help machines process and classify data. But here's where it gets interesting. The machine doesn't just learn, it tests itself, and the results from those tests help refine the algorithm. The machine adjusts its internal parameters, improving its accuracy. Machine learning can be broken down into three major types: supervised, unsupervised, and reinforcement learning. Let's quickly explore each one. Supervised learning is when the machine is trained on labeled data. For instance, feeding it 10,000 pictures of cats, all clearly marked as cat, helps it build a model that can predict the label of new pictures. This is how Google Photos can recognize faces in your pictures. Unsupervised learning is when the machine is given data without labels and asked to find patterns on its own. This is used in clustering. Think of it as how Netflix learns your preferences without you explicitly telling it. Finally, reinforcement learning. Here, the machine learns by interacting with its environment and receiving rewards or penalties. Think of this as how AI-controlled characters in video games improve, or how self-driving cars learn to navigate roads. This method was used by DeepMind to create the AlphaGo program that defeated world champions in the game of Go. Now let's talk about what's truly mind-blowing: neural networks. These intricate systems are revolutionizing the way we approach problem-solving and data analysis. This technology is modeled after the way neurons in the human brain work. Just as our brain's neurons fire and communicate with each other to process information, neural networks use artificial neurons to perform complex computations. Each layer of the network processes a little bit of the data and passes it forward, just like how your brain breaks down a visual image into edges, shapes, and eventually into recognizable objects. This layered approach allows neural networks to understand and interpret data in a hierarchical manner, making sense of intricate patterns and details. Deep learning models like Google's AlphaStar trained itself to play the complex video game StarCraft II, beating professional players just by processing the game data over and over again. This achievement showcases the power of neural networks in mastering tasks that require strategic thinking and adaptability. These models get so good because they are fed enormous amounts of data and simulate thousands of games, learning strategies even humans can't comprehend. By continuously analyzing and learning from vast datasets, neural networks can develop a deep understanding of the task at hand, improving their performance with each iteration. This ability to learn and adapt is what makes neural networks so powerful and versatile in various applications, from gaming to medical diagnostics and beyond. Machine learning isn't just about improving Netflix recommendations. It's transforming healthcare, finance, and transportation. Imagine AI diagnosing diseases with more accuracy than doctors, or algorithms that can predict financial markets better than humans. A study by Stanford University found that AI systems can already detect some forms of skin cancer with an accuracy level matching top dermatologists. Meanwhile, AI in finance has been revolutionizing investment strategies through high-frequency trading, where algorithms make decisions in fractions of a second, something no human could ever achieve. However, as powerful as machine learning is, it's not without its challenges. These challenges range from technical issues such as the difficulty in training complex models to more profound societal impacts. One of the biggest concerns is bias. Bias in machine learning can manifest in various ways, often stemming from the data used to train these models. If the data used to train a model is biased, the predictions will be biased too, potentially leading to unfair or even harmful outcomes. This can affect everything from hiring practices to loan approvals and even criminal justice. The infamous Compass algorithm used in the US judicial system, for example, was found to disproportionately misclassify black defendants as high risk. This has led to significant debates about the role of AI in critical decision-making processes. This raises important ethical questions. How do we ensure AI is fair? How do we prevent these systems from perpetuating existing inequalities? These are not just technical challenges, but moral ones as well. As we continue to push the boundaries of AI, ensuring ethical and fair machine learning systems will be just as important as the technologies themselves. Researchers and developers are now focusing on creating algorithms that are transparent, accountable, and fair. This involves not only technical solutions, but also interdisciplinary collaboration to address these complex issues. Machine learning is revolutionizing the world, whether you realize it or not. The future is here, and it's being shaped by algorithms. Want to learn more about the future of AI? Hit that subscribe button and stay tuned as we uncover even more mind-blowing developments of machine learning. Let's dive into its real-world applications. Autonomous vehicles are one of the most talked-about applications. In healthcare, machine learning is revolutionizing diagnostics, predicting diseases, and personalizing treatment plans. Retail is also seeing the benefits, from AI-powered checkout systems to personalized shopping experiences tailored to individual preferences. Smart homes leverage machine learning to adapt to our routines, making life more convenient and efficient. In finance, machine learning analyzes market trends, detects fraud, and helps in making informed investment decisions. Manufacturing is getting a boost too, with predictive maintenance and quality control systems that reduce downtime and improve efficiency. Urban planning is becoming smarter with traffic management systems that reduce congestion and improve public safety. Even education is being transformed, offering personalized learning experiences that cater to each student's unique needs. These are just a few examples of how machine learning is integrated into our daily lives, making the impossible possible. As machine learning continues to evolve, its integration into our lives will create a future where technology and humanity thrive together. Yes. The future of machine learning is not just about technology, it's about creating a better world for everyone.